Okay guys, we're going to do a system of equations by graphing. I am far from an expert at this video stuff, but hopefully this will help. So, we'll start out with two equations. And what we're going to do is solve the system by graphing. So, it is exactly how it sounds. We're going to graph both of those lines. So this should be nothing new to you since we've done this for a couple weeks in the bell ringer. Let me draw my coordinate plane here. If you do not have graph paper, it's okay. Just draw yourself a coordinate plane, do the best you can. The first line, I'm going to do it here in this purple color, or pink. Remember, y equals mx plus b, slope-intercept form. The number at the end out here is where we start on the y-axis, the y-intercept. So for this one, we're going to start at 5. From there, we need to know the slope. The slope is the number to the x. Here there is no number, so remember there's a 1. We also need to be a fraction because slope is rise over run. So remember, any number as a fraction is over 1. So we start at 5 like we already did. We're going to go down 1 over 1. And draw your line. Do your best. Nobody's going to expect it to be perfect. And there you go. Just like the bell ringer. The next one I'm going to do in orange. I'm not sure if you can see those colors or not, but I'm trying to keep everything separate. We're going to start down 1, y-intercept. From there, 2 is 2 over 1, so we're going to go up 2 over 1. And draw your line. Now, sometimes it's going to be hard to figure out where they cross because that is the solution. The solution is where the two lines intersect. Here, I can't really tell if it's over 2 up 2, over 2 up 3, over 3 up 2. I have no idea. So we're just going to guess one, see what happens. Let's say we guess over 3 up 3. Let's see if that works. So here's our guess. So what you're going to do is you're going to plug in a 3 for all your x's and a 3 for all your y's, and we're going to see if the equations are true. I am going to rewrite the equation just because this is going to get messy. So I'm plugging in a 3 for all my x's, and I'm plugging in this 3 for all my y's. And then ask yourself, does 3 equal negative 3 plus 5? Well, negative 3 plus 5 is 2, so I already know it's wrong. So I know this guess is not correct. Let's try 2 comma 3, see what happens. So I'm going to slide down a little bit here. And I'm going to rewrite the equation, so we're guessing 2 comma 3. You do not have to keep writing these over and over. I just want to show you how to do it. If you have a pencil, you can erase. So now let's plug in a 2 for all your x's and a 3 for all your y's. So now, does 3 equal negative 2 plus 5? Yes, it does. And it must work for both. We can't stop yet. Does 3 equal 2 times 2, which is 4, minus 1? Does 3 equal 4 minus 1? Yes, it does. And we know, therefore, this is the solution. And that's really all there is to it. You've been graphing lines for a few weeks in the bell ringers, so now we're just trying to figure out where they cross and plug in to verify it works. Other than that, oh, okay, another thing they'll do. Sometimes on your worksheets or SATs or ACTs, they will give you a set of equations. And they'll just give you a bunch of things to plug in, and you got to pick which one works. You don't even have to graph it. So if they give you multiple choice where you have 2 equations and a bunch of these ordered pairs, you just go and plug them all in until you get one where it works in both equations. Hopefully that helps. I'll get a few more difficult ones here in a second.